Hello, and welcome back to the STM32 Q/G Advanced Debug feature. I'm Bruno, and I'm your host for this video series. So let's dig into our serial wire viewer debug session. I'm just going to switch to STM32 Q/G using the very same code as I've been using so far. Before we jump into the debug session, I just wanted to highlight that we are also gonna use the serial wire viewer to trace the event and exception. So it's important for us to understand that there are a few interrupts that can happen on this project, and the most common one is the actual sysdig handler. So we can see here it's basically doing a simple increment tick and is the one responsible to ensure that our HAL delay actually works throughout the entire code. But I'm also going to use the ITM port. So as you guys remember, I had a macro defined here that is pretty much making use of one of the 32 ITM stimulus ports that we can play. And throughout the code execution, I'm going to use the very last one, so the third one, to change from 1 and 2 prior to going into the main loop. So this will actually allow me to monitor this transition and the time it's spent in this part of the code execution as well. Alright, now that we have the basis layout for what to expect, let's start our debug session. Now that I'm on the debug perspective, all I have to do is go to Window, Show View, Serial Wire Viewer, and select the trace log. With the trace log, I can actually go to the configuration trace, and starting by the ITM stimulus port, I need to make sure that the number 31 is the one selected, because it's the one that I'm referring to on my code. And just to keep and make sure that our log is pretty clean, I'm removing the exception trace log as well. So that way each and every exception is not going to be shown on the log at this point in time. So by hitting OK and starting our trace, I can actually resume the code, and I'm just gonna hit suspend right now because the very first information that I want is right here at the beginning. So we have the sync right at the same cycle. We can see that we also have the ITM port number 31 with the data number 1. So if we roll back to our code, we can actually see that the ITM port is the number 31, and we selected the value 1 to be placed to it. So this one is actually reflecting to this particular line of the code. And if we do scroll down a little bit, we can actually see that we are calling again the same macro, but this time we are issuing the number 2, and we can see this one reflecting on the code. So the very good information is that you actually have a pretty precise timestamp that it took for performing all these actions. So the initialization of the GPIO, the DMA, the UART, and the printf function. So all of that took around 0.12 milliseconds. Great. Now we do have the information from the ITM port that we manually selected. So that's a very easy way to measure the amount of time spent without using the usual toggle with a scope method. And a very useful thing that we're going to actually change right now on our code, that we're going to back on the serial wire settings, and I'm actually going to re-enable the trace exceptions right now. So by adding the trace exception to rerun, we can now see that the exception is recurring is actually the sysdig. So by pausing the program, I can actually go into the trace log, and I can see that the majority of the exceptions was caused by the sysdig. As you may know, the sysdig is set to happen every 1 millisecond. So if we analyze the timestamp between the trace exceptions, we can actually see the 1 millisecond being held here and here and here. So it's always 1 millisecond between the execution trace log. Alright, so the last feature that I wanted to cover with you guys is shown through the, again, window, show view, serial wire viewer, and is the statistical proofing. This is the only one that requires the application to be running for a while to then how to show the information. So to ensure that we all have the same configuration here, I'm enabling the PC sampling, the timestamps. I've kept the previous trace exceptions, and I'm also using only the port 0 as the default I removed the 31 for this particular measurement. So by hitting OK, I can start the trace and then start the code execution. I'm gonna wait for a few milliseconds, and now that we have plenty of time already spent, I can suspend the application and it will actually show to us the amount of percentage time it spent on each and every function. So of course we are going to spend most of our time on the how delay and the get tick, which is part of the how delay function, and we can see that's roughly 99.86% of our application is spent there. There's also a lot of time spent on the system handler, so all these three functions are part of the combined how delay, and we do have a small amount of time spent on the items and char because of the printf functions. So if we actually want to make our code slightly more proficient, we can see where it's spending most of its time. So this is very similar to the task manager of your firmware, so you know where you're spending most of your time. You can decide if this makes sense or not for your application code. In our example, it does a lot of sense because it's using a huge delay and it's taking most of our processing time on that. So that was it, guys. I hope you had fun watching how to use the SerialWire viewer. Don't forget to like and subscribe for more content. And if you need further information, please visit st.com. Thank you.